CorGIE is a tool for exploring correspondences between an input graph and its node embeddings produced by graph neural networks in order to evaluate the quality of a machine learning model. Let me demonstrate the CorGIE interface with the movie dataset. The machine learning application is to recommend movies to users. As I color code the nodes with node types, in the latent space view we can see that there are two types of nodes, movie in blue and user in orange. The view next to it, latent neighbor blocks, show the topological neighbor distribution in the latent space. The node feature view shows distribution of node features such as movie budgets. The global topology visualizes the whole input graph. The distance comparison view compares distance in latent topology and feature space between pairs of nodes. Let's check out the interesting clustering structure in the latent space. First, I highlight one cluster in the green zone on the left. In the pop-up menu, I click to focus on the highlighted nodes. Notice that a new scatter plot is created in the distance comparison view to show distance within focal nodes, and a new row in the node features view to show their node features. A new k-hop topology is computed to show the focal nodes and their neighbors by hop. You see that there are three subclusters here. We add another focal group of purple nodes. We can explore their topological difference in the k-hop topology. We enable the neighbor highlighting for inspection. When we brush the purple nodes, we can see that they connect to only 4 of the red nodes, but the green nodes connect to all. Here we can also see that the 3 subclusters connect to different red nodes. This is a good sign that the GNN has learned from the topological neighbors to separate the nodes into different clusters. In the distance view, if we look at the latent distance distribution, we can see that the distance within focal groups are much lower than the distances between the groups. If we look at the topology distance, the distance within focal group 0 is quite high, potentially due to the subclustering structure. We can switch to the feature distance. Both within and between distance are all low, which is a bad sign that GNN did not use the node features well, or this feature does not have the ability to distinguish nodes. Let's review the movie recommendations by GNN. We select a user from the graph, say 544, and click Predict to show its top 5 recommended movies. Then we click the first one, The Lord of the Rings. CorGIE will automatically create 2 new focal groups and put the user and movie in them respectively. In the k-hop topology, we can hover to see what movies the user has rated before, and the users of these movies. It turns out that the users of these movies also watched the recommended movie, Lord of the Rings, proven by their overlaps in the Hop 1 neighbors. This indicates that GNN might have made a good recommendation based on the graph topology. We have found some bad recommendations as well. For example, another user, 5355, is also recommended to watch Lord of the Rings. But when we hover on the movies that this user had seen before, that is, the 2 pink nodes in the middle, there are very few overlapping nodes in the Hop 1 neighbors compared to the previous case. That is to say, the audience of these 2 movies might not be interested in Lord of the Rings. When we turn to the distance view, we notice the disparity between the topological distance 0.97 and the latent distance 0.05, which aligns with our observations in the k-hop topology. The potential reason could be the lack of data for this user, who has only watched 2 movies in this dataset. Let me show you another dataset, Quora. This is a citation graph of academic papers, and we train a GNN to predict the topic for each paper. The latent neighbor blocks here overlay the topological neighbor distributions on the 2D latent space. Each block represents the nodes in the corresponding position in the latent space. Within the block, we nest a copy of the latent space to show the neighboring structures of these nodes with a heat map. The red outlined cell is the corresponding position of these nodes in the nested copy. Notice that the red outlined cells and their surrounding cells are among the darkest of all cells, which is a good sign that the GNN has placed the neighbor nodes in nearby positions. The node features here show distributions of sparse features, that is, the binary word presence of each paper. Each small rectangle here represents one word. The papers with this word are highlighted upon hovering. The strip above is an aggregated form of the matrix, with each strip represents a few words. When we have a few focal groups, we can compare the word occurrences between different sets of papers. We can highlight the papers that are different in terms of specific words. In summary, we demonstrate CorGIE to find correspondences between an input graph and its GNN node embedding.